And the thing is, like, if you trap moisture, like here in Tassie, it's a pretty good picture because, like, when we use these good old aluminium foils are a perfect vapor barrier, sitting in this case on the outside of the structure. The wind pressure will just drive the moisture through all gaps and cracks, even via capillary. So that's for me. Before I said, okay, let's figure out where the problems are really. Guten Tag, Australia. As you might guessed already, I'm originally from Germany, from Munich. Yes, let's talk about moisture managed construction assemblies in Australia and New Zealand. Of course, I'm based in Sydney. That's why I chose this beautiful picture. But we want to talk about building physics and flat roofs. But before we talk about the flat roofs, we actually want to understand the circle of priorities, I call them. And when we have a building, we have certain impacts and requirements and priorities. We have water, we have vapor, we have thermal, and we have air. And now I want you guys to ask yourself, what do you think is the most important, and then the second most important impacts on structures, or on the structure. And I'll give you another 5 seconds to think about it, and then you'll see if you're right or not. So, because normally it's a person-to-person presentation. And the answer is, in my opinion, is actually water. First, then air, then vapor, and then thermal. And the reason is why. If you ask me, what's with water? And if you just look over the ditch to New Zealand, and there's a nice book called The Rottonomics, and New Zealand still has to deal with massive, massive problems of water leakage and problems. Very important next topic, and this is about vapor. And because as we build airtight, we feel warm now. Now we actually still produce moisture. We cook, we have a shower, we sweat. We produce moisture all the time, and it's free floating in the air. So what's happening with all the moisture? As we know, as a family, you produce around 200 liters a week of free floating moisture in the air. What's happening with all the stuff? As we know, airtight, it means kind of it can't get away. So normally vapor always goes the way of the least resistance. The first way was like convection, and now it doesn't work anymore. So now it starts actually to try to travel through the structures, which is called diffusion. So it means now it starts to diffuse through the walls in this case. And as plasterboard is highly vapor permeable, you can't consider that we have a lot of resistance in our structure. So it means we have to protect our structure from moisture traveling in a structure with a smart vapor control layer, which we're going to talk about later. So now we trap the moisture inside. Part 2 would be we need actually a ventilation concept. And the thing is, like, if you trap moisture, like here in Tassie, it's a pretty good picture because, like, when we use these good old aluminium foils are a perfect vapor barrier, sitting in this case on the outside of the structure, is a nightmare. And this can happen after a few years of a structure. So that's why you can't have vapor barriers on the outside of the structure, which we're going to talk about it too. Handling and understanding moisture means kind of you have to understand different types of leaks. We have an energy leak, which in my opinion is most times when you have a thermal bridge. So if you have a steel structure or steel beams, which are attached to the outside and the inside, you could create cold surface on the inside. And this is when you create something called a thermal bridge, pretty well known from the passive house movement. And you could have mold spots on your plasterboard on the inside. A more tricky one is a moisture leak, which would be actually via convection again. So it means kind of you have a leak on one end, slowly the warm, moist air is traveling to the outside. It will condensate on the way to the outside. And this would be a typical moisture leak because you have on some random spots, you have actually mold and condensation and rotten timbers. So that's why I will always recommend understand these two types. So finally, going to the flat roof is kind of why do we build flat roofs? And we all agree that's actually a pretty nice view here. It's in Clovelly in Sydney. And the worst case, what can happen is that you have a building site. So at the moment, there is actually a massive building site in front of this house. And the worst case can happen is the whole nice few $1 million view is completely blocked now. And we all agree that's not what you want. So now the big gambling and negotiation will start. We try to fight for each single degree on your roof because you want to get it down. And now it makes sense why we actually want to go down to 2 degrees, because at least you have something left from the ocean view, isn't it? So there's a reason, because we have height restrictions, specifically when we live in dense areas. We're not talking about outside of big cities, and we want to have the views. To find out where the problems are and how to solve them, because the problem is when you have a low pitch roof, it takes quite a while for the water to run off. At 2 degrees, sometimes water is just sitting there, and if you have a little bit of wind pressure, water can't run off at all. So it means you have water sitting on your joints and on difficult junctions, wind pressure, because you have wind today, and the wind pressure will just drive the moisture through all gaps and cracks, even via capillary. So that's for me. Before I said, okay, let's figure out where the problems are, I really wanted to understand the problems. To be code compliant for membranes, you have to hold 100 millimeters of water for 24 hours, which equals 1 kilopascal. And to be honest, like when I was building this box, it was back then during COVID, I was pretty confident. So I thought like, easy. I know exactly what's happening and I know it all. I'm smart, and I just started it. And I came up with all sorts of funky ideas and basic ones, and it was leaking. So there was a first kickback. So actually, I wasn't as smart as I thought. So I had to change my detail, and I used a specific stretchy tape to actually seal it around. Then about the chimney, I really came up with a super fancy origami taping technique, how to tape around chimneys, because I wanted to avoid other products. And I thought, it must work for sure. And 3 or 4 corners leak too. So another big learning for me. So I had to change it again. I went back to the stretchy tape because I just realized having the right products for the right applications on the end is fast and cheaper. And this is how it went all the way through. And this is how I came up with the Flat Hero system. Where I'm pretty precise how things are working. And as always, we have to think it as a system. So and it doesn't matter if you talk about our Proclaimer products or if you talk about other competitor products. We always think about systems, not products. It's very important. And also it's important to understand how a structure is working. So it means the roof structure, we always trying to create the highest drying potential of this roof structure. So that's why you always recommend having a smart vapor control layer on the inside to stop internal moisture getting in our structure. And we want to have the highest drying potential to the outside too. And we also have to understand that building materials are never 100% dry. My experience here in Australia is quite often the opposite. So sometimes it feels like we're trying to introduce as much moisture in the structure before we cover it up with membranes. So the important part is like we have to keep our structure dry over the whole period of time. When you have a standing seam, it's kind of tricky one. So the standing seam, specifically in this buildup, you really always have to have a separation layer. So you can't have standing seam directly on the membrane, because otherwise you have a cold surface hard against the membrane, and you're pretty surely you might end up with a soggy board. So that's why this separation mesh, even if it's just 8 millimeters, allows a drainage layer for the standing seam or flat metal roof. Very important to say, this is not a ventilation layer. This is just a pure drainage layer and separation layer. And this system has to work with the smart vapor control layer only, because there's nothing else which can actually make it work. Also, as this will be never ever a deemed to satisfy solution, you have to do woofy calcs, and the matter of the roof, the color of the roof will matter. And in quite a few climates and orientations, you actually have to go with a dark colored roof, because a white colored roof, I know that the market is driving to white colored roof because we don't want to have overheating of our roof structure. But if you have a white colored roof, you might have not enough energy to allow your moisture to drive back, because in summer, when sun hits the roof sheets, it actually creates a reverse moisture drive. Now your structure can dry out to the inside, because we have this magic smart vapor control layer in here. Same with materials, also can dry out to the inside. Very important is, the better case is always if you can separate your roof sheeting from the membrane, as you can see here, and you proper drained and ventilated roof structure. The thing is, as we have a very, very low roof pitch, we have something like a stagnant effect. So we don't have a proper ventilation layer anymore. And that's why the ventilation heights will get more and more and more. So we say, like, if the roof is up to 10 meters, you should have minimum 50 mil ventilation layer. If the roof is longer than 10 meters, you should actually have 150 millimeters ventilation. I know no one will do it, but it's very important to mention, because the international studies from Germany, from the Lund University, from the US, that ventilation is very important to actually get rid of moisture. And these are based on the German standards. I know it will take a while before we implement them, but I think it's very important to understand the risk of moisture in our roof cavity. We have quite a few technical articles regarding this topic, and it's called Above Sheeting Ventilation. Technical articles, you can all download them on the Proclaimer website.